Hello guys, so today we're back with another question, which is Leetcode problem 240. Search a 2D matrix. Write an efficient algorithm, blah blah blah. So it says integers in each rows are sorted in ascending from left to right, and columns are also sorted in from top to bottom. So it means it's sorted this way, and it's sorted this way, this way, this way, this way, this way. And what that means is that we can actually have several ways to solve this problem. Of course, you can use the brute force way, which is like going through every array, every element, and finding the target, which would be O of m times n. And let's actually do that. I want to see if it works. For I in range of matrix, length of matrix, and for j in range of length of matrix of 0, if matrix I j equals target, return true, and if it doesn't, return false. And when you run this code, of course it works, and it also works for this, because I would say we don't have a terribly big array, I would say. But we want to do better than this. So what we can do is that we could actually not go through all of this, but we could go through each row and do a binary search by it. And what I mean by that is that we could do binary search, which is PS in matrix array and target, and we're gonna set left equals 0, right equals array dot, not array dot length, array -1, and we are gonna do a binary search. And let's say we do binary search. If it exists, return true, else return false. And we're gonna use this binary search PS function for each row. So it would be, we would have to have one group which is in range of length of matrix and matrix I. If matrix I comma target, return false, not false, true, and if it doesn't, return false. That's pretty easy to do, I would say. So what we have to do is to do binary search. And the way we do binary search, we could optimize this a little bit more, such as do a function if the target value is smaller than the first value of matrix I, which would be this, then return false. So if, let's say for target 20 and for target for target 5 we didn't find it here, but if we come to this row, 10 is bigger than target and everything else is even bigger, so we don't even want to look at the rest of it. We can just return false. And also, so we can just put this even before this, and we can optimize, like, let's comment out first, and we could optimize a little bit more as if target is smaller. Okay, so we could optimize a little bit more by not only doing this, but doing or target is bigger than matrix I last value. So this means if it's bigger than the last value, then the former values will actually be smaller than the last value because this is sorted. And it will return false. Let's actually run this first, and it works. Wrong answer. 20. Oh, I didn't do the binary search part. I'm sorry. So let's do the binary search part. While left is equals right. This is like normal binary search. So mid equals left plus right. Integer division 2, and after that we'll see if array mid equal target return true. Elif array mid is smaller than target, that means we're going to make left to mid plus 1, and else right equals mid minus 1. And if this while loop ends, that means we're not finding this, so we'll actually, so this is true. And how about this? Yeah, this is actually a little bit faster. How about we optimize it with this? Is it gonna be more faster? Maybe. What? Okay, so there's an edge case. If length of matrix equal 0, or length matrix of first value equal 0, then return 1. False. Would this work? Let's actually see. Try this and try this. Okay, it works. So wrong answer. 5, 6. Doesn't find 5. So it means we have a problem with this BFS, because this BFS does not find this. So let's actually see inside this BFS what's the problem here. So what if this only has one value, 0 and 0. Then mid will be 0, and let's actually print out left, print right, and see what happens here. So it's not even going here. Oh. Huh, so it's actually going here. Yeah, that makes sense because it's not about the binary search function, it's about this condition, because this is the only thing we added. So that means the first value is bigger than target, or the last value. Oh, so I don't really understand. Why is this happening? Print target and print matrix I. This will show you where we have the problem. We don't need this. It says 6 and 5. Oh, I see. Huh. Okay. So I guess we cannot have this at here, but we can have this for sure. Yes. So it's not as fast, but to actually have the other thing, you can just check if that row, if the target is in the row or not. So this was the slightly better solution, which would be not O of mn, but it would be O of let's say we have m elements each row and we have n rows. This would be log m times n. So this is an improvement, but not that much of an improvement. So what do we actually want to do here? And can we're actually using the fact that the rows are binary, but we're not actually using the fact that the columns are also binary. So what we can do here is that we can do a greedy approach, and we can start from, I think we can start from the top right corner and see if like we can start going down until so the reason why we're starting like at the top right is that everything in the row, it's going to be smaller than this. So if it's smaller than this, we can traverse like downwards and leftwards, and if it's bigger, then we can go upwards. And if it's like bigger than this, like let's say this was something like we're finding something like can't find a good 9, I guess, then we can go 15 11, 7, and after that we can see that 7 is smaller than 9, so we're going to go below, and then we find this. So this is not a mathematical proof of it, but we can see that nothing is like, if it's bigger than the top rightmost, you have to go downwards until you find something which is the element that would be bigger than the target you're going to find. So let's say we're targeting 20, so we're going 15, 19, 22, and we want to go down. And so we're basically neglecting the right upper side of our path, because you know that like if something is like smaller than the target when you start here, you can neglect the whole row. You can just neglect it. And if it's the same way, if it's bigger than if it's smaller than 15, you can neglect this whole column itself. So you can just go to 11, and still 11 is bigger than 5, so you can neglect all the column here. You can go to 7, and you can neglect all the columns there. So by just iterating 2 elements, we have excluded the whole 3 columns. By doing this, we can neglect everything by n plus n. So this way, we're going to have n plus m. And let's actually implement it. So I only have a few minutes. So we're gonna start from the top rightmost, which is going to be matrix of top right would be 0, comma length of matrix of 0. Let's actually get the edge case here. If length of matrix equal 0, or length of matrix 0 equal after this, length of -1. Yeah, and I will just say not, like we'll just say index, and while let's say while true, and just say if matrix IDX 0, we have to actually make this to array so that we can add it. And IDX 1 equal target, then return false. Oh no, true. And after this, let's actually print this to see if we're doing right. IDX. Else, if we're gonna use this a lot, so we're gonna put this out, and not target, but what do you call this? Let's say value. Let's say value. If value is target, value is smaller than target, then we want to exclude all the row itself. So we're going to do matrix 0, no, not matrix 0, idx 0 plus equals 1, and else, which would be value is bigger than -1. So that would be idx 1 to be minus equals 1. So let's actually test this with the test cases we have. First we will start from 15. Sorry about that. And we'll go to 11, 7, 4 has it, and 5, and it will return true. How about 20? We'll go to 19, 22, 16, 17, 26, 23, 21, 18, and then we don't have anywhere to go anymore. So yeah, so that would be the if index idx 0 if idx 0 is out of range. It's the x value, so becomes smaller than 0, or idx 1 becomes bigger or equal to length of matrix, then return false. I think this will work because idx 1, what? No, it's the other way around. Yeah, it's the other way around. Length matrix, if it gets bigger, it's the x value. So if it gets bigger than this, or equal to this, or idx becomes smaller than 0, then we're gonna return false. 0, 0. List indices must be integers or slices, not tuple. What? This is not a tuple. Value equals matrix. Oh, I'm sorry. Yeah, this will do. Okay, so 5, 6. Okay, I want to test this. I really want to see what it's going on here. Can I see? Maybe I should go for new tab and run code, your input. Okay, got it. Run code. So it goes 0, 4, 0, 3, 0, 2, 0, 1. What? No, it starts here, sorry. 0, 0, 1, 2, 3, 4, 0, 4, 3, 2, 1, and then 1, 1. Nice. Let's submit this, and it takes 36 minutes, but it's O of n plus n, believe me guys. And for the space complexity, this would be also fine. I mean, like, for space complexity, everything is fine. But that was, I really like this problem. This is a good brain teaser, like excluding the columns and excluding the rows. This was a brilliant method. I didn't bring this up, but I did bring up the brute force solution. So have fun and have a nice day, guys. Bye.